If you do not have a certain date in which you know there should be a break, then you could test for a break in a certain time range. And this is calculated as the quant likelihood ratio. Okay, so this is just well, it's not a modified version of the Chow test, but it's just to run the Chow test for all possible break dates in a certain range. So for each of the dates within a tau 0 and tau 1, you test the hypothesis of a break with the f-test, and you record the size of the f-test, and you choose the largest one. To go a bit deeper into this, then, okay, there is a lot of text here, but we're going to go through this systematically. Okay, so the QLR test is the largest Chow F test. Okay, and we need to decide upon a certain range of dates where we are going to perform the test. And the QLR is the maximum value of these F values. Okay, so you just look at, okay, which F value was the highest, and that would be your QLR test statistic. Okay, so one of the most important properties is that the distribution of the QLR statistic depends on Q, which is the number of restrictions being tested in the model. For example, previously we looked at the ADL11 model, and we see here that we had three different restrictions, and our restrictions was that on the gamma naught, gamma 1, and gamma 2. Okay, so here we have three restrictions, and the QLR statistic depends on this number of restrictions to find the critical value which we want to compare our QLR statistic to. And the QLR statistic also depends on the ratios of endpoints to the sample size, which is just tau naught divided by the total number of observations. So, for example, just a minute. And the endpoint is tau 1 divided by the total number of samples. And the standard here is to use 15% trimming. So if tau, or if large T equals 100, so we have 100 days, for example, of observations, then tau naught would be day 15, okay, and tau 1 would be day let's see, 85. Okay, so, and between these days you would run the test. So if you know the number of restrictions, and you know the trimming, which you just set to 15%, then you know which critical values you should compare your QLR statistic to. And the QLR statistic for 15% trimming can be found in this table. So, for example, with 3 number of restrictions, the QLR statistic is 4.71. So, which means that if you find an F value, the maximum F value, to be above 4.71, then you know that at least one of the restrictions or the coefficients on the restrictions would be greater than 0 or different than 0. And the second step here, after you have found the number of restrictions and you have found your sample size, then you can run the test, and this QLF test can detect whether or not there is a single discrete break in which you would have a certain spike in your F value here. So, for example, this was low, and suddenly you get very high values, and suddenly you get very low values again. Then you know that, well, this tau x here is probably the break date. Okay, but if you have like this very slowly evolving pattern, then that would be an evidence of a slow evolution of the change in the regression function. But we have to remember that this test actually tests for one break, not several breaks. So if there is a single discrete break in the population regression function, then the period that we find, actually I can change this to tau hat, okay, then the QLR test statistic is a consistent estimator of the break date, which means that this tau hat is unbiased if there is one single break in the population regression function. And the f-stat, or the QLR statistic, can be used to test for a break in all the regression coefficients, or just some regression coefficients.